To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all the third question of paper 2 part A of the O-Level 2020 paper. So in the previous chapter I started off discussing the paper 2 with you all, and in that I discussed the first two questions, that is the two structured questions of part A. Now this is the third question. Third one, A part. The following figures indicate the lattice structures of three solid substances P, Q and R. So, if you look at the figures, you all can see the three lattice structures. So, you all know what lattice structures are, students. Those are very large array of constituent components arranged in a three-dimensional array. So, it can be an ionic lattice, it can be an atomic lattice, or it can even be a molecular lattice. So, if you look at the three diagrams, I am sure you will be able to identify them. Look at this first one. There is one atom bonded with four other atoms in a three-dimensional array. So, immediately you all can recognize this as the diamond lattice. It is an allotrope of carbon, a crystalline allotrope. This is a diamond lattice and it is an atomic lattice. And you know these bonds are all covalent bonds. Each carbon is bonded with another four carbons. That is why diamond has very high strength, very strong. The hardness is high, it has very high refractive index. All the properties are related to the lattice structure. High melting point, high boiling point, all that related to the lattice structure. Then the second one, you all can see here, students. Now one atom is bonded with, now if you take this one, three other atoms, and these atoms are joined in a hexagonal shape. 6 atoms are combined together. Like that you have one sheet, another sheet. Between the sheets you can see these broken lines. You know there is an interaction. So that also you all are familiar with. This is a graphite lattice. Immediately you can identify this as a graphite lattice. Again an allotrope of carbon, a crystalline allotrope. But here one carbon is bonded with three other carbons by covalent bonds. So this alpha here, both of them denote the covalent bonds. And there you can see between the two sheets of carbon, there is a free electron on each carbon. So there is an electron cloud. Between the electron clouds there is interaction. That is how the graphite gets its property. The lubricant property, ability to conduct electricity, brittle nature, all that because of this lattice structure. Again, it is an atomic lattice structure. Then the last one, look at it. Now, there are two types of atoms shown. Then you know this is not an atomic structure, actually it is an ionic lattice. Two different ions and the sizes are different, and if you take one ion, the middle white color one, if you take 1, 2, 3, 4, 5, 6 black color ions, there are 6 ions. Around one white there are 6 black color ions. Same way, if you look at these black color ions, you all know there are 6 white color ions around it. Then immediately you all can confirm that this is a sodium chloride lattice, an ionic lattice. So this beta is the ionic bond between a sodium ion and an chloride ion, the positive and a negative ion. So the first two are atomic lattices, diamond, graphite, then sodium chloride and ionic lattice. So you have identified the lattices. Now if we look at the questions, identify them and fill in the relevant blanks, selecting the names of those substances and the lattice structures from the box given below. So we have already identified them. Sodium chloride, diamond, graphite, ionic and atomic. So you need to fill this space. Substance, what is it? It is diamond. Diamond. And what is the lattice? It is atomic. Again, substance, graphite. They have filled the lattice as atomic. Then substance, sodium chloride. Sodium chloride. And lattice, ionic. So that is all you need to do here. With that, I'll move on to the next part. Part 2 of the same question. Write the names of the chemical bonds labeled alpha and beta in the lattice structures. So we have already identified the alpha and beta. Just to confirm, here you can see alpha in diamond, alpha in graphite. So you know it is the atomic lattice. Between carbon atoms there is covalent bond. Then beta is between sodium and chloride ions. So it is the ionic bond. So here alpha is covalent bond. And beta is ionic bond. You all know the difference. In a covalent bond, electrons are shared between atoms. In an ionic bond, one atom loses the electrons and forms the cation, whereas the other atom gains the electron and becomes the anion. And the interaction, electrostatic interaction between the two ions is the ionic bond. So in an ionic lattice, there are ionic bonds. In an atomic lattice, there are covalent bonds between the atoms. Then, third one, of the substances P, Q and R, A, which substance conducts electricity in the solid state? Diamond does not conduct electricity. Graphite, yes, it conducts electricity in the solid state. Why? Because there is a free electron in each of the carbon that forms an electron cloud. So that helps to conduct electricity. It is a very good conductor of electricity, graphite. But sodium chloride, although it's an ionic compound, in the solid state, all the ions are fixed charges. They are not mobile. They cannot move. So, because there are no free mobile charges or mobile ions, it cannot conduct electricity in the solid state. But when it becomes the liquid state, ionic compound in a liquid state, that is fused sodium chloride or molten sodium chloride, or else the solution, aqueous sodium chloride, conducts electricity well. So, ionic compounds don't conduct electricity in the solid state, but they can conduct electricity in the liquid state or the solution state. So, the component that can conduct electricity is graphite. So, here if you look at the diagram, graphite is Q. So, what you can do is, of the substances P, Q and R, so there you can write the answer as Q or you can write the answer as graphite. Either way, it will be accepted. Since in the question they have asked P, Q and R, you can write it as Q, or since you have already identified it, you can write it as graphite. Then B part, which substance has the highest hardness? That I already mentioned to you all. Now carbon, both allotropes, diamond and graphite, but graphite is brittle. The same way, if you take sodium chloride, now by just crushing it, you can crush salt and get the powder. You don't have to apply a very large force. But you can't do that for diamond. Diamond is one of the strongest metals, strongest element on earth. So, the diamond lattice is the hardest structure given there. Highest hardness is diamond. Again there, we can write it as P or diamond. Because the first lattice, P was the diamond lattice, so we can write it as P or diamond. Is that clear, student? So, you have to read the questions carefully and answer them. With that, I'll move on to the next slide. Here we have part B of the same question. There. Part B. Given below are two reactions in connection with the metal M. Now this is a new metal M. Look at the reactions. M with oxygen gas, when you heat, there is a substance X formed which is a white powder. Then M plus Y gives rise to magnesium chloride, which is an aqueous solution, and component Z, that is a colorless gas. So here, first the metal plus oxygen gives you a white color powder. From that itself, you can identify. Normally when you burn magnesium is a metal. When you burn it with oxygen, that's why heat is provided, you get the white color powder. It burns with a bright white flame and a white color powder is obtained. That is magnesium oxide. At the same time, M with Y gives you magnesium chloride and a gas. So you all should identify that this is hydrogen gas. Now we have already identified this as magnesium plus oxygen. So this is going to be magnesium oxide. This will be a colorless gas, means hydrogen gas. And here, since they say magnesium chloride, now MgCl2. Now you all know this from the reactants and products, you can easily identify it's a single displacement reaction, and also since you are getting Cl2 here, the Cl2 and H2 should combine. So Y should be HCl, hydrochloric acid. When magnesium reacts with hydrochloric acid, you will get magnesium chloride and hydrogen gas. So like that, you should be able to identify the reactants and the reaction. Then, if we answer the questions, identify M, X, Y and Z and write their names or chemical formulae on the dotted lines. So here also you can write the name or the chemical formulae. So for M, we can write it as Mg, or you can write it as magnesium. So I am writing both. You can just write one. You can either write Mg or magnesium, and you don't have to use the same format for all. Here you can write the chemical formula, here you can write the name. That's also fine. So X, we have already found it as magnesium oxide. So again Mg, or you can write it as magnesium oxide. Magnesium oxide. Then Y, we found it as HCl. So HCl or hydrochloric acid, chloric acid, even you can write it as hydrogen chloride. Hydrogen chloride. Now here students, HCl, they haven't specified whether it's the aqueous state or the gaseous state. Usually aqueous is hydrochloric acid. If it is in the gaseous state or just HCl means, you can refer to it as hydrogen chloride. So you can write any one of these answers. HCl, hydrochloric acid or hydrogen chloride. And Z we identified as H2 gas. So here this is H2 or hydrogen, or you can even write it as hydrogen gas. Hydrogen gas. You can just leave it as hydrogen, or you can write it as hydrogen gas. Is that okay? So the main thing is to identify the components correctly. The reactants and the products and the reaction correctly. Is that clear, student? So then I'll move on to the next one. Second part of the same question. In compound X, the ionic form in which M exists is M2+. Write the chemical symbol of the ionic form in which the oxygen exists in that compound. So if you look at what X is, X we identified it as MgO. So MgO. Now in MgO, this is being done in the opposite manner. Now here they have said in MgO, Mg exists as 2 plus. Now you can see the valency, the chemical formula, this is actually the ratio between the ions, Mg2 plus ions. Since it is MgO, it has to be 1:1 ratio. 1:1 ratio. So obviously they have to have the same charges. So this has to be 2 minus charge. Or else if you write the valency, magnesium belongs to group 2, oxygen belongs to group 6, so valency 2. When you exchange, you get it as Mg2O2. But since these two values are same, we write it as MgO. So in MgO, if magnesium is in the 2 plus state, oxygen will be in the O2 minus state. Is that clear? So that is how we get MgO. So in compound X, the ionic form in which M exists is M2 plus, that is Mg2 plus. Write the chemical symbol. So you need to write this of the ionic form in which oxygen exists in that compound. So you have to write O2 minus. So here of course you have to write the chemical symbol. Is that clear, student? Then X is sparingly soluble in water. Which color litmus papers give a color change when testing that aqueous solution with litmus paper? Now X is what? Already here we saw X is magnesium oxide. Now if you take magnesium oxide, you all know oxides of metals are basic. And from that we have discussed the acid-base properties. You can remember the third period, sodium oxide is strongly basic. But magnesium oxide is a weak base. And this is sparingly soluble in water. Now sodium oxide dissolves very well in water to form sodium hydroxide. But magnesium oxide dissolves slightly in water. That is why they say sparingly soluble in water, and it forms magnesium hydroxide, that is also a basic substance. And what is the litmus? There are two colors, one is blue litmus, the other one is red litmus. Now blue litmus becomes red color with an acid, whereas the red litmus gives a blue color with bases. So here, since magnesium oxide is basic, in order to identify that it is basic, we need to use a red litmus. So here they have asked which color litmus papers give a color change when testing that aqueous solution with litmus papers. So here we have to say red litmus. Red litmus. Because MgO, when you dissolve it in water, you get magnesium hydroxide. That is a basic substance. So you need to use red litmus paper. Here they have not asked for the color change. So we don't need to write that. You only need to write the litmus paper. Is that clear, student? So with that, I'll move on to the next slide. Then we have question number 4. Question number 4, A part. In an activity to demonstrate Newton's laws. So they have mentioned the activity, Newton's laws. A trolley connected to two equal masses M with string is used. So look at the diagram given here. You can see the trolley. There are two strings with equal masses M are connected. Then the figures show 3 instances in the activity. So these are 3 instances of the activity. Instance 1, instance 2 and instance 3. In those instances, the slack strings are represented by wavy lines while the taut strings are represented by straight lines. Slack strings are these with the wavy line where the string is loose. There is no tension there. So that means you can see here the mass is resting on the floor. So because of that there is no force exerted. It is a slack string. Now this one is taut string. Taut means the stiff string. So there is a tension. That means you can see here, now the mass is hanging. So the mass will be downwards. The weight of this object will be downwards. So there is a force being exerted downwards. Because of that, there is a force, that is the tension exerted on this string and on the trolley. So that is how they have represented it. The loose or the slack string means there is no force. The taut string, there is a force acting. That is how you have to identify. So here you can see both are slack strings. So there is no force acting on either side. Here you can see this side, there is a force. This is a taut string. Here there is no force. It is a slack string. Is that okay? Then the strings are made to pass over two smooth pulleys A and B fixed to the two ends of the table. So A and B are pulleys fixed to the two ends of the table. Arrows indicate the direction of motion of the trolley, which smoothly moves on the horizontal table, and the directions of motions of the masses. So here they indicate the movement of the trolley. So in all the instances, now they have said horizontal table. You all know why we always use a horizontal table. Now when it is horizontal table, the force acting on it, the friction exerted by the table, but here they have said the trolley moves smoothly. So that means the friction is very less. So the trolley can move smoothly, and also it's only due to the force exerted. Now if it was an inclined plane, inclined table, then there will be other forces due to the gravity. But here that effect is not there, only due to this pull. The force applied by the mass, there is movement. That is what you need to understand. So in instance 1, you can understand, students, there is a force acting towards B, because you can see this M is pulling down. The weight is moving downwards. The weight of M will be downwards. So because of that, there will be a force acting this way, a force acting this way. Now if there is an unbalanced force, what will happen to this trolley? Trolley will accelerate. And since it is the weight, it is an unbalanced force with a fixed magnitude, then of course there will be uniform acceleration of the trolley towards B. Direction of the arrow is towards B. Now here they have shown the movement of the trolley, but both sides the strings are slack strings. So there is no force acting on it. Both the masses are resting on the floor. So that means there is no unbalanced force, but still the trolley is moving. Then what will be the motion? It will move with constant velocity or uniform velocity. If there is an unbalanced force, there will be uniform acceleration. Here, there is no unbalanced force, then there is no acceleration. Uniform or constant velocity. Then the third instance is what? Here you can see the trolley is moving this way. This side the string is slacking. So that means there is no force on this side. But here you can see they have shown the movement this way. But still the weight of this object will act downwards. So that is going to give a force down, but the weight is moving up against the gravitational force, against the gravitational pull. So what do you all think? This will be moving slowly. At the same time, there will be a force pulling the trolley down as well. But the trolley is moving in the opposite direction. So there what is happening? There is a force being exerted against the direction of movement of the trolley. So that is an unbalanced force, and that will give rise to a deceleration. The object will, or the trolley will decelerate. You all have to understand that, because the pull is this way, but the trolley is moving opposite to that. So it will decelerate, and that will be a uniform deceleration. So those are the things you need to understand. Then here you can see this is going to be uniform acceleration. acceleration, then uniform velocity, and here uniform deceleration. Then in the question they said it's to identify the Newton's laws. So what do you all think? First one, uniform acceleration. If there is acceleration, F equals ma, so Newton's second law. Then uniform velocity means there is no unbalanced force. So Newton's first law. Again, the uniform deceleration, that is also like acceleration, F equals ma, negative acceleration. So this is also Newton's second law. So only two laws, Newton's second law and Newton's first law are tested here or demonstrated here. You can understand that. Right. So then we'll move on to the questions. First one. Inserting appropriately the terms given in the following box, complete the following table which describes the nature of motion of the trolley in the instances 1, 2 and 3. We have already identified it. You can see uniform retardation. Retardation refers to deceleration. Retarding means reducing. So the velocity reducing, the trolley becoming slower. So that is deceleration. Uniform retardation means uniform deceleration. Uniform acceleration, uniform velocity, Newton's first law and Newton's second law. So we have to fill in the table. Instance 1, 2, 3, nature of motion of the trolley and Newton's law that describes the nature of the trolley. Now we have already identified them. So first one, nature of motion of the trolley, uniform acceleration. Uniform acceleration. Then Newton's law, Newton's second law. Newton's second law. Newton's second law. Then instance 2, uniform velocity. Uniform velocity. So here this is Newton's first law. First law. Then the third instance, again you saw it was uniform retardation. Uniform retardation. Uniform retardation. Now, when I wrote it in the activity, the diagram, I wrote it as uniform deceleration, but I told you all uniform retardation means uniform deceleration. Here they have already filled it for us, Newton's second law. So, is that clear, students? So, this is how we fill up the table for the 3 instances. With that, I'll move on to the next one. That is the second part of the question. In one of the above instances, the trolley took 5 seconds to travel 50 centimeters on the table with uniform velocity. Find the uniform velocity with which the trolley moved. So here, when you do a calculation, it's very important that you write the equation. So first, to find velocity, what is the equation? Velocity equals displacement divided by time. You have to write that. Then, now here you can see the time is given as 5 seconds and the displacement is given as 50 centimeters. And they have said it's uniform velocity. So there, you can directly use these units. It's not the standard unit, but since it's given this way, you can use it as it is. 50 centimeters divided by 5 seconds. So you will get the answer as 10 centimeter per second. But when you write the answer, you have to write the correct unit. Always, when you do a calculation, write the equation and you have to write the units, the correct units. You can do it this way. So here 50 centimeter divided by 5 seconds. So you get the answer as 10 centimeters per second. Or else you can convert this to the standard unit. Then you do the same thing. You need to write the equation. Velocity, displacement over time, but here when you do, you can divide this by 100, so you get the answer in meters, divided by 5 seconds. So that is going to be 50 divided by 100 divided by 5 seconds. That will be 50 over 500 meters per second. That is 0.1 meters per second. So here you can do this way as well. You can convert it to meters. So 50 divided by 100, then you divide it by 5 seconds. So 50 divided by 500 when you rearrange, or you can get it as 0.5 divided by 5 seconds. That is also okay. Just to show you all that, if you divide, here I can write it. You don't have to do everything. You can even write this as 0.5 meters divided by 5 seconds. So that also will give you the same answer. So one of the methods, you can use the units centimeters per second, then the answer will be 10 centimeters per second, or else you can convert it to standard units, meters per second. So the answer will be 0.1 meters per second. Both methods you will get the marks, the same marks. So you can follow one of the methods. But if they tell you in the question, find the uniform velocity in standard units, then of course you have to use the second method. You have to convert centimeters to meters. So depending on how they ask the question. Here they haven't mentioned about the units, so you can use any one of the methods. Is that clear, student? So with that, I'll move on to the next part of the question. That is part B. The figure shows a cuboidal block of wood used to examine how the frictional force between a horizontal surface and an object placed on it changes. So if you look at the diagram, you can see a horizontal surface is marked there, a cuboidal block of wood, and they have marked the force W down and force R up, both acting along the same line of action. Then here you can see a Newton balance is connected and a force of F is applied towards this direction. So that is what you can understand from the diagram. The block of wood is connected to a Newton balance by a string and a horizontal external force F is applied. So here also they say it is a horizontal force F. The experiment is conducted by increasing the value of the force F gradually from 0. So this is starting from 0, they increase the force and they observe what happens. Right. So that is the activity. Now let's look at the questions. First one, name the forces indicated by R and W. So here what is R? Normally when an object is at rest, you all know the weight of the object acts downwards, that is W. And equal to the weight of the object, there is a force exerted by the horizontal surface. What is that? It is the normal reaction or the perpendicular reaction. So what is marked as R? R is the normal reaction, or we can write it as perpendicular reaction. Normal reaction or the perpendicular reaction. Then what is W? W is weight. Now instead of writing it as weight, you can also say the force exerted by the object on the surface of the table. That also is accepted. So you can say the force exerted by the object on the table. Or we can say the force due to gravity, because the weight is the force mass into gravitational acceleration. So that is the force exerted due to gravity. So we can say that also. Force exerted due to gravity. So you can write one of the three answers. Normally we are used to writing it as weight and normal reaction or perpendicular reaction. But you can also say the force exerted by the object on the table. So force exerted due to gravity. Or else you can even say gravitational force. Gravitational force. So here you can write any one of the answers. That is more than enough. Is that clear, students? So normally, like I told you all, the structured paper, they give enough space for the particular answer. But here, since I am writing all the possible answers only, I am taking up more space. So you will be writing only one answer. Then there will be no problem. So with that, students, I'll move on to the next part. Then the second part of the same question. The block of wood stays at rest until F is increased to a certain value from 0. By what name is the frictional force acting on the block of wood known before it starts to move? So you all know what friction is, students. Now you are familiar with that. When there is a block that is trying to move in a certain direction, there is the friction acting in the opposite direction. When we start this force from 0, now this is the frictional force, this is the force exerted by us. When we start from 0 and then we increase it, what happens? Initially, according to the force, there is equal and opposite force exerted by the surface. That is the frictional force. That is to prevent the motion of this object when it is trying to move. So there it keeps on increasing, but still the object is at rest. So we call it the static frictional force. And as we increase the applied force, the static frictional force increases and reaches a maximum value. And that maximum value is known as the limiting frictional force. Thereafter, if you apply a higher force, then of course the object starts to move. And when the object is moving also, there is a force being applied, that is the frictional force, which is known as the dynamic frictional force. So you have the static frictional force that increases with the force applied, reaches the maximum value, that is the limiting frictional force. But after the object starts moving, the dynamic frictional force is slightly lesser than the limiting frictional force. So there, the dynamic friction is less than the applied force. That is why there is a unbalanced force and the object is moving. Is that clear, student? So here, according to this question, what is the first instance? The block of wood stays at rest until F is increased to a certain value from 0. By what name is the frictional force acting on the block of wood known before it starts to move? That is static frictional force. Static frictional force. Static frictional force. Then I'll move to the next part. So here, third part. At the moment the motion starts, the frictional force acting on the block of wood reaches the maximum value. So I told you all these. What is the name of that maximum frictional force? It is the limiting frictional force. Limiting frictional force. frictional force. Then B part, write two factors on which the magnitude of that frictional force depends. Limiting frictional force depends on two factors. You all can remember the nature of surface, nature of the contact surface. When it is smooth, the frictional force is less. When it is a rough surface, the limiting frictional force is high. And the second factor is perpendicular reaction or normal reaction. When that increases, when the perpendicular force increases, the limiting frictional force also increases. But the surface area does not affect the limiting frictional force. You all are familiar with that. So the two factors, write two factors. One is nature of surface, and the other one is normal reaction or perpendicular reaction. So you can either write it as normal reaction or perpendicular reaction. And you all have to keep in mind, students, the surface area does not affect the limiting frictional force. Then, the next one, C part. Suggest a method that can be practically applied to change one factor you stated in B above. Now we have stated two factors. How can you change one factor? Now if you want to change the nature of surface, what can we do? We can either increase the roughness or decrease the roughness. To increase the roughness, what do? We normally fix a sandpaper. You can remember there are different sandpapers with different roughnesses. So to test the effect of nature of surface, that is what we do. We paste a sandpaper on the block of wood, and with that we try to repeat the activity. So by fixing a sandpaper, attaching a sandpaper, you can increase the roughness. How can you reduce the roughness? You can make the surface more smoother. But here we have the same block. So what we can do is we can put powder. Talc powder can be used to smooth it. Like in a carom board, you can remember that. So that can be done to change the nature of surface. So we can say attach a sandpaper to the block to increase the roughness of surface with that we can say use talc powder to reduce the roughness between surfaces. You can do that. What if you consider changing the normal reaction or the perpendicular reaction? What do? You can remember normally we have the block of wood. On top of that we have another block of wood, or what we can do is we can keep another weight on that block of wood. So to increase the normal or perpendicular reaction. So there we can say, or you can write, place a weight on the block to increase the normal reaction. So that also you can do, students. So you have to write only one method. They have asked suggest a method that can be practically applied to change one factor you stated in B above. So you can write one of these. You can say you can attach a sandpaper to the block to increase the roughness of the surface, or you can say use talc powder to reduce the roughness between the surface, or you can say place a weight on the block to increase the normal reaction. But when you write the answer, you make sure you say what factor you are changing. Now here I have said changing the roughness, that is nature of surface. Here I have said to increase the normal reaction. So like that you have to mention the factor and how you can change it. But you need to write only one. Is that clear, student? So with that, I have completed the structured questions given in your paper. This is part A of paper 2. So with that, I am going to end this chapter, and in the next chapter, I will discuss the essay type questions. That is part B of your paper 2.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.